Okay, so today we'll work on the remaining modularization techniques in ABAP. So yesterday we have seen how to create include programs and subroutines. So there are a few other options in subroutines like pass by value, pass by reference, and returning internal table data. So there are few other concepts, okay, which we will discuss in miscellaneous concepts, okay, at the end, because as I told you, subroutines are not our priority, at least for S4 HANA or recent projects. Okay, so our priority should be on object oriented programming, that is classes and methods, and next priority would be function modules. Okay, so now we'll work on the function modules. Before going into function module, I'll show you one more additional option for subroutines, and we'll see pass by value and pass by reference and miscellaneous concepts. Subroutines. I'm removing everything. So it's our yesterday's program. I've just deleted everything. So yesterday we have seen how to pass the parameters as input, but we did not return any output, right? From subroutines. Now we'll see how to return output. First define a, so again, here we have to, you can follow top down or bottom up approach. First you can define the form, add numbers, sorry, form, yeah, form and end form, and then you can call your subroutine here, right? Or the other approach is first call your subroutine name, and double click on it. Okay, yes, create the subroutine. So I want to create it in main program. So what it is proposing? So it is proposing to create a new include program with for this new subroutine. For now, just see this new include program option. Select the new include program. Continue. What? Create it and select the include program option. Maybe, yeah, no. Here you need to change the include program name. It is proposing some name with standard program name. Just make it Z. Okay, Z. Just add Z to that, and maybe it is too long. Continue. So a new include program is added. Activate the include program. Go back. So here a include program is automatically added right at the end. Why it is at the end? Because it contains subroutine declaration, subroutine definition. So all the subroutine definition should be at the end, right? That's why this include program is automatically added at the end. So whatever the subroutines you create here, perform, divide numbers, why it's always from, create the subroutine, double click, yes, select the include program, whatever we have already created, this one, right? This include program. Now all your subroutine definitions will be added to this include program, right? Now, for example, if you need same functionality, whatever we implemented in the subroutines here, what you can do? You can use this include program. You can use this include program in another program, right? You can use this include program in another program and just call the subroutines. Okay? In that way, you can reuse whatever the functionality available in these subroutines. But we cannot call same subroutine in another program. But how can we reuse this subroutines logic? If you keep that subroutines definitions in an include program, and you can reuse this include program or use this include program in another executable program, right? So in that way you can use functionality whatever we implemented in the subroutines. Okay, now just write some logic. I'm just removing everything. So create from the beginning. Here what are our input parameters? P underscore 1 using to pass the inputs. The statement is using p underscore 1 space p underscore 2. To return the output, what is the statement? Changing. Changing is the statement to return the output. What is our output parameter? LV underscore output, right? So we are calculating our final output to this variable. Changing LV underscore output. Okay. Now double click on it. So I want to keep my include in a separate include program. Okay. So select the include program, or if it is not available, create your own include program. Now observe this, there is no difference, right? So here I have added this to include program, or instead of include program you can just keep it here. Okay, like this. But for reusability, if you keep it like this, whatever the code inside this subroutine, right, you cannot reuse it in another program, correct? Because subroutines are local to the same program, you cannot reuse it in another program. But if you have very similar functionality you need to implement in other program, what you can do? You can keep this subroutine definition in include program, and you can reuse it, include program in other programs. Okay. Now write your logic inside the subroutine definition. What is your logic? Here, these are your formal parameters. What do we call this? Please make a note of this. These are formal parameters of the subroutine. What is the actual parameter? Please observe two terms, formal parameter and actual parameter. These are the actual parameters. What we are passing here? These are called actual parameters. What are the formal parameters? These ones. Whatever the parameters automatically created in the subroutine definition, we call them as formal parameters. Clear? Is everyone clear? Actual parameters versus formal parameters. This is also interview question. Okay. So whatever the parameters we are passing in perform is called actual parameters. Whatever the parameters we are using in subroutine definition, formal parameters. Okay. Now you can also assign any data type if required. Here, type I. Okay. If you want to specify a specific data type, you can also assign data type here or any data element. Okay. That is also possible. P underscore LV underscore output equal to 1 plus 2. That's it. Activate this. Go back and activate the main program. Now execute. Oh, sorry, I'm not returning any output. Let me return the output, or I'll use write statement. Execute 30, right? So this calculation we are doing inside the subroutine, and we placed that subroutine definition in a separate include program. Okay, let's see how we can reuse it, how we can reuse this functionality. As I told you, can we reuse subroutines in any other program? Subroutines are local to only same program. So, but now what I did, I placed my subroutine definition in a include program, separate include program. Now let's see how we can reuse it. Go to another program. Let's assume we have very similar functionality required in a different program. Let's call it as subroutines 2. So in the other program also, I need a functionality to calculate, sorry, add two numbers. Create the program. I'll just copy these two parameters. So if you want to reuse the functionality, what you need to do, you need to call the subroutine, right? Let's call this subroutine. I'm calling the subroutine here. Is it going to work? What it is saying? Add numbers does not exist, but it is available in other program, right? Since subroutine can available only for the same program, it cannot be accessible by other programs. That's why it is saying add numbers are not available. Now let me copy this include program and paste it here at the end. Always make sure if your include program contains subroutine definitions, where you need to keep that at the end after all the executable statements. Okay. Now no syntax errors. Activate, execute. Am I able to reuse the functionality or not? Am I able to reuse the functionality available in subroutine or not? Yes, right? So in this way, you can reuse the code or functionality, whatever available in subroutines. Okay, but you cannot call same subroutine. These are local to same program. Okay, and yesterday, so one of you asked one question like how, since we are creating lot of reusable objects, how can we identify what is the reusable object suitable for my requirement? How can I know whether there is any reusable object already created to use, right? So I told you how to find it, right? There are multiple ways. Okay, checking the documentation, check with your team, senior resources, right? And check with your common class methods, whatever created. The other way is, I'll show you the other way. Please observe carefully, it is very important. So let's say I'm trying to find a functionality which is already implemented for purchase order report, right? Purchase order report for data selection, for data selection logic. Can you tell me the very important table of purchase order? EKKO, right? Yeah. Now I'm going to EKKO table in data dictionary, display. Display is not really required. Even you can find it from here also. So enter the EKKO table. Here you can find what is this? Where user list? Where user list? Okay. Click on where is the list. Select different objects. What type of objects you are expecting? Programs, classes, function modules. I'm selecting these three. Okay. I want to find any programs that contains EKKO relevant logic. Click on continue. Yes. So what are these? These are all the, so these are DDL sources. These are CDS views. We'll look into this when we are working on ABAP HANA. These are the function modules where this EKKO table is being used. These are all standard function modules. Let's scroll down. Scroll down to custom, which should starts with the Z. Looks like there is only one standard function module, ZDemo select function. Double click on this. So this is anyway, we'll see that later. Still we didn't discuss function modules, right? Let's go to the programs. So these are the programs, right? Scroll down to the programs. So these are all the programs where that EKKO table is being used. Okay. Uh, can we find our program Z demo, right? It should be the top. This one. Double click. Double click on the code. So here we are using EKKO, right? Here you can find join condition on EKKO table. What type of program? I think it's executable program. Go back. What is the reusable program we have created? For example, this one, PO data 3. I think here also. So it is a include program, I think. Go to attributes and check what type of program it is. Oh, it is also a executable program. So where is the include program? So yeah, you can observe, right, all these programs are referring to the TKKO table in some logic, right? You can go through one by one. So here, since it is a practice server, you can find many junk programs, but in your project you can find only few programs which are using EKKO table. Okay, right, you should find the executable program. Okay, so also we have a lot of methods here, right? Classes, methods, function modules. There might be a class method available, there might be a function module available, right? So since we haven't discussed the function modules and class methods, I am just showing you programs. Here you can find the include PO selection or include PO selection logic. Double click, go to attributes and check what type of program it is. Anyway, here itself you can find it's a include program. Okay, or you can find in attributes. Go to program attributes. It is a include program. So you can find, okay, there is a logic to select PO related data, PO data, right? If it is suitable for your requirement, just use this include program or copy this select and do minor modifications whatever you need. Okay, let's say you need to add more fields, you can add here, not in the include. But if you add it in the include, if you do any changes in the include, it's going to impact all the programs which is being used by this include program. Correct? If always remember, when you are changing any reusable object, including function module, include program, subroutine, and class method, first you have to do impact analysis, because if you do any changes to those objects, okay, whatever the programs calling that object will be impacted, right? Before changing, do some analysis. So if I do this change, what about the rest of the programs using the same object? Is it going to disturb the functionality of the other programs or not? If it is disturbing the other programs functionality, just use the logic, just copy this data selection and create your own reusable object, or use the select statement in your program by doing modifications. Okay, clear? Now I'm in the include program, right? Now I'm in the include program. Now how can I know that wherever this include program is using, what are all the programs that this calling this include program? Just select the program. Here also you can find reused, where used list. So it will show wherever this program is being called. Click on where used list, select the programs, continue. So there are, how many programs are there? There are two programs which are calling this include program, right? Program 1, start of selection, it is using same include program. Go back, program number 2, in start of selection, it is using same include program. So this is how you can find the where is list. Clear? Where is list is very important, like very helpful when you are working on the projects, right? You don't need to break your head if you don't understand some logic, or if you don't know how to select data from some table, right? You don't need to break your head. First check, is there any logic already implemented by someone in the project, right? How can you check that? That will help you to build the logic, right? If you don't know how to select data from EKKO, enter the EKKO table and check where is the list. For example, only programs, check where is the list. So these are all the programs that is using EKKO in their data selection. Just open any program, just see how they have implemented the select statement, right? So you will have some hint, right? You'll have some help, right? So by looking at this, you can understand. By any chance, if your requirement also very similar, do you need to write any code here? Even you can just copy and paste in your program, right? The entire data selection, correct? or whatever the select statements require. You can just make use of the select code in your program, right? Or you can find the logic and you can do minor modifications, correct? Yeah, no problem. Huh, right, correct, correct. Yeah, but before that, if that change is required for all the programs, right? Whatever the change you are applying to that reusable object, that is common for any program, for all your programs in your project, then you can go ahead and do change the include program, no issue, or include or whatever reusable object, function module or method. Whatever the change you are going to do, it is common for all the programs. That functionality should be added or that functionality should be removed for all the programs, all the applications. You are okay to change in the same include program or function module or class method. But whatever the change you are doing is specific to your program, and that is not applicable to rest of the applications. And what you need to do, don't change that include program or class method. Create your own include program or create your own class method, right? In that, copy that code and paste here and do your changes. Then rest of the applications are not going to impact, right? You have to analyze that. Is that change what I am doing is required for other programs also, or this change is only for the specific application, not for rest of the programs, right? If it is common for all programs, do it in the reusable object. So whatever the programs or applications using that reusable object will be automatically, that functionality should be automatically available for all the objects. You don't need to go to individual program and change it. That is another advantage of this modularization. When there is a specific functionality, you don't need to change in every program if there is any changes or enhancements required. You can just apply that change to the reusable object. It will automatically apply for all the applications. Okay. For example, this PO data selection is being used in 100 programs, right? And we did not use reusable object. Let's say after 1 month or 2 months, your user asked you to add one more field to the data selection, that is purchase order type. Then what you need to do, if you are not using modularization, you have to go to all 100 programs and change it, right? One by one. Let's say you have already modularized it in an include program or class method or a function module. Then your business consultant or functional consultant asks you to add few additional fields to the data selection. Then what you need to do, you don't need to go for all 100 programs. Just go to that reusable object and add those additional fields in that reusable object. That change will be applicable for all the programs, correct? Maintenance is very easy. That is the advantage of modularization. Okay, when someone asks you about modularization, what is modularization? So modularization is a creating reusable blocks so that we can reuse the functionality, right? And modularization helps to maintain objects. Okay, it is very convenient to maintain the objects or functionalities, right? That's it. Please practice even even you can go to the table level, and even you can find the fields also where this field is being used in the program. Let's select Booker's company code and click on where is the list. Let's confine to the programs for now. So these are all the programs that Booker's field is being used. Open this here. That company code field is referring here, right? Like that, you can find, like let's say someone asks you to select a material number and you don't know how to select the material number. What you need to do? Go to Mara table, display, select the material number field, click on where is the list, select the programs. For now, like later you can select all the objects once you have gone through classes and function modules. Continue. So these are all the programs that material number Matner field is being used. Scroll down for custom programs. These are all the standard programs. Scroll down for custom programs. Double click on any program. So here that material number is referring, right? Matner. It will directly take you to that field. Here also that material number is referring. Like that you can find wherever we are using that material number, and you can find the relevant logic, and you can make use of that relevant logic in your program. Clear? Mat details. Here also that is being used. Okay. That's how you can find. Okay. You can use where is the list in your projects. You can apply where is the list on any objects, including data elements, domains, tables, structures, views, programs, function modules, class methods. You can apply where is the list on any object so that you can find where this object is being referred. Okay. Where this object is being called. Okay. So yeah, I think it's already 9:30. I don't want to take much of your time for today. Tomorrow we'll continue with the modularization techniques like function modules, and we'll see the next modularization technique is class method. Okay, function modules will take time. Okay, because it is very important thing we need to discuss. So okay, we'll continue in the tomorrow's session. So please practice whatever the objects we have created till now. Okay, if there is any pending objects also, please try to complete the practice today.